In this video, let's practice writing interval notation for quadratic functions. So jumping right into it, for number one, we have this function of f of x is equal to this x squared minus 9x minus 36. Now this is a quadratic function written in standard form. To go ahead and write interval notation, it's going to be helpful to know our zeros or x-intercepts. So factoring this is going to be super useful. Okay. Now just looking at this x squared, we know that the factors are going to be x and x. So I'm going to write 1x and 1x because that multiplies to get x squared. Now looking at the negative 36, we are looking for two factors that multiply to get negative 36 but add to get to negative 9. I think I'm going to go with a negative 12 and a positive 3. All right, so if I pair up these factors here, if I multiply across, that's me negative 12x plus 3x, that's going to equal negative 9x. So that being said, if we go ahead and write this factored form, then this function is going to be f of x is going to be equal to this, let's see, we're going to have 1x in the beginning of one of the binomials, and we have another 1x at the beginning of the other. For the outers, I'm saying it's going to be minus 12, and then for the inners, I'm going to say it's plus 3. I guess it doesn't really matter here, though, because since a is equal to 1. But this pairing here of this 1x and minus 12 were my outers, essentially, and then this 1x plus the 3 was going to be the inners here. So feel free to swap those, but that would be the factored form here. So now that the quadratic is factored, we can look at this binomial on the right side. Because of this binomial of x plus 3, we know that if x was equal to negative 3, then this binomial would become 0 and the whole function would equal 0. And if we take a look at this x minus 12 binomial, if x was equal to positive 12, then we'd also have an x-intercept here. All right. So if we want to find out what the zeros are, we can go ahead and say that one of the zeros, I'm going to write the zeros here, are going to be negative 3. If x is negative 3, then y would be 0, or f of x would be 0. And we can also say here that if x was 12, then y would also be 0, or f of 12 would equal 0. All right, so what does that mean? Well, it means that if we were to just make a really rough sketch of this function right now, we can go ahead and say that this negative 3 comma 0, that would be maybe over here, that would be an x-intercept, and then this 12 comma 0 would be somewhere over here, over on the positive x-axis. And if we go ahead and sketch this, then our function would look something like this. Again, this is just a very rough sketch, but this is what our quadratic function would look like here. We know it's opening up since a's value is equal to positive 1. Okay, so now that we know what it looks like, let's go and see if we can write our interval notation. All right, so starting off with the domain here. Domain is basically what is the function doing as you go to the left and as you go to the right. But if we take a look here, this function is going up to the left and it's going to keep going to the left forever. And as we go to the right, it's going to keep going to the right forever as well. So nothing's going to stop this function from keeping on going. So if we say the domain here, it's going to go to the left to negative infinity. We're going to use parentheses because we never put brackets on infinity. And then we're going to go ahead and say this goes to the right forever, or towards positive infinity. So domain is really just saying how far to the left does this function go and how far to the right does this function go. All right, now let's talk about the range. For the range, that's going to be the lowest point of the graph, which is going to be down here. It hits some lowest point here, it doesn't go down forever, and then what's going to be the highest point. So notice how this function is going to go up forever. Now for the range, we're actually going to use a bracket here for the lowest point since it does touch a lowest point, and I'm going to use parentheses on the right side. Now we do know it goes up forever, so we're going to say as we go to the higher end of this graph, it's going to go up forever. And let's see, we have to figure out what the lowest point of the graph is here. And the lowest point is going to be where this vertex is, right? Now the vertex, we need to figure out what the AOS is first. That's going to help us find out the x value for where the lowest point occurs, and then we can figure out that lowest point. Okay, so how do we figure out that AOS? Well, the AOS, try to recall here, is going to be the middle of this function. So there's a formula. We can say x equals negative b over 2a. This is one way to figure out that AOS. Negative b would be negative 9, which is positive 9. And 2a is 2 times 1, which is 2. And so this is going to be 4.5. So now that we know the x value for the vertex, let's go ahead and figure out the y value. So let's find out what f of 4.5 is. Let's go ahead and say that's going to be plugging in 4.5 in for x, so 4.5 squared, and then minus 9 times the 4.5, and then minus 36. Okay, so you can either do this by hand using fractions, or you can go ahead and do the multiplications out and subtractions and everything, or use a calculator. And I believe this is going to end up being negative 56.8 0.25. Okay, so somewhere down on the negative part of the y-axis. So the vertex here, I'm going to write the vertex. The ordered pair for that is going to be positive 4.5 comma negative 56.25. All right, so that way we know what the lowest point of this graph is. That's how far down this point is going to be. So I'm going to write negative 56. I'm going to write a quarter, just keeping it as a fraction here instead. All right, now that we know the domain and range for this function, let's go ahead and see if we can figure out when is this function increasing. Now, if we take a look, if we look at the graph going from left to right, as we are moving down this graph, or going to the right rather, notice how the function is decreasing, 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 until we get to the vertex, then the function starts increasing, right? So when are we talking about the function increasing? That's really just talking about where it's at its lowest point and then starts moving upwards as we go to the right. So at this point right here, which is this x value of 4.5, notice how that's the vertex. This function is going to start increasing. Okay, so put a parentheses there because it's not actually increasing at the bottom, it just starts increasing there. And as we move to the right forever, it's going to keep on increasing, right? The graph is never going to stop increasing. It's going to just keep going up and up and up and up and up and up as we keep on going. All right. Now, what about when is the function decreasing here? Decreasing, well, it was always decreasing, right? It was still going down, 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 down forever until we hit that vertex. So if we go to the left forever and we're moving to the right, it's going to be always going to be decreasing all the way up until that 4.5. Okay, and it's going to be decreasing until you get to that 4.5. That's when it starts increasing. All right. Next, we're going to talk about when is this function positive, and that's we talk about positive, we have to look at the x-axis. So when we talk about positive parts of this function, it's when is this graph above the x-axis. So this is where the function is positive, and this is where the function is positive. Okay, so it's positive from here up until this x intercept, and it's going to start being positive at this x-intercept, and then as we move to the right. Okay, so for the first one, it's going to be positive from negative infinity up until that first x-intercept, which is going to be -3. Okay, remember at -3, it's not positive or negative, it's 0. And we're going to use this little u to show union, so it's also positive where else. Well, it's going to start being positive at this x-intercept, which is 12, and it's going to keep being positive from thereafter. So from 12 to positive infinity, this function is going to be positive as well. Okay. So again, for this part, this is saying it's positive over here, it's above the x-axis, and then from here, it's going to start being positive again. So it's taking a break, and that brings us to when is this function negative. And again, for when it's negative, it's when the function is below the x-axis. So this whole piece of the function is negative, and it starts being negative here. It's negative, 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 negative. It's still negative up until here, right? So basically it's just the x-intercept. So from -3 up until +12, this function is negative. Here is number 2. For number 2, we have a different function here. We have f of x is equal to this x squared plus 6x minus 16. Let's see if we can turn this into this factored form first. So we have a equals 1, so we know it's going to just be 1x and 1x. And then for this -16, we need 2 factors. We need a +6 in the middle, so let's go with maybe a +8 and a -2. If we go ahead and multiply, if these are our outers and our inners, then that would be 8x minus 2x, which is 6x. So if we go ahead and write this in factored form, what are we going to have? I think we're going to have, let's see, we're going to have f of x is equal to, and then we're going to have x in the beginning here, and then x in the beginning here. And then we're going to have x minus 8 for the outers, and then, or sorry, x plus 8 for the outers, and x minus 2 for the inners. I guess it doesn't really matter which one's first, but that does work out because a is equal to 1. So where are x-intercepts? Well, if we look over here, then we know that x equals +2, or the opposite of that -2. That would be one of our zeros. And here it would be x equals -8. Okay, so what are our zeros? We can say our zeros here. If x was equal to +2, then the whole function would equal 0, the y value equals 0. And if x was equal to -8, then the y value equals 0. So those are our x-intercepts. just making a really rough sketch here. Let's go and see what this would look like. Here's our x-axis and our y-axis. Positive 2 would be maybe somewhere like here, and a negative 8 would be over here. And so just a rough sketch, since a is equal to 1, we know it's going to open upwards. And our graph or our function is going to look something like this, just a rough sketch. All right, so domain for quadratics is always going to be all real numbers. So again, as we go to the left forever, and we can go to the right forever, this function is always going to go to the left and to the right forever. And then let's talk about the range. The range here is going to be the lowest point to the highest point. We do have to figure out this lowest point right here, okay? And then the highest point is it's going to go up forever. So the lowest point is going to get that bracket, like in the last example, and the highest point is it's going to go up forever, okay? Just because there's nothing stopping it. And so how are we going to figure out the lowest point here? Well, let's start with figuring out the AOS, axis of symmetry. That's going to be x is equal to negative b over 2a. So go ahead and look at our coefficients here. Negative b would be negative 6, and then 2a would be 2 times 1 or 2. This would be negative 3. Okay, so if we take a look, this would be our axis of symmetry, and we just figured out that that would be x equals negative 3. So let's go ahead and see if we find out. Let's find out the y value now. So f of negative 3. If we plug that into our function, that's going to be this negative 3 squared, and then plus 6 times this negative 3, and then minus 16. Okay, so if we go ahead and see what that's going to get us, again, you can go ahead and do all these steps out, but I believe we should end up with a negative 25. So that means for our vertex here, we can say that that is going to be, if x is negative 3, then y would be negative 25. Okay, so that's going to be this point right down here. The lowest point then we're going to say is going to be this y would equal negative 25. That's what we just figured out from this. So that's going to be the lowest point of this graph. Okay, so the range is the lowest to the highest. All right, so when is this graph increasing? Okay, so the graph starts increasing at the vertex, and it starts increasing, and it's just going to keep going up forever after that. So it's going to start at what x value? Well, the x value for here is going to be negative 3. So it's going to start increasing at negative 3, and it's going to increase forever after that. Okay. What about when the function is decreasing? Well, it's going to be decreasing up until that x equals negative 3. So if you go to the left forever and we're going towards the right, it's decreasing, decreasing, decreasing up until negative 3. That's when it stops decreasing and it's going to start increasing. Next, what about when the function is positive? That's, again, we have to look at the x-axis. Here's the x-axis. It's positive when it's above it, so it's positive here and it's positive here. So let's take a look at this part first. It's going to be positive from the left all the way up until this x-intercept of negative 8. So to the left forever means negative infinity, and then up until that negative 8. So let's go ahead and say it's going to be positive there. Then it's going to take a break. It's going to be negative for a little bit, and then when does it start being positive again? Well, it starts being positive at this x-intercept, which is 2. And it becomes positive from there on after. So it's going to pick it up again from 2 up until positive infinity. Okay, so that's when the function is positive. Finally, when is this function negative? Well, the function is negative when it is below the x-axis. So that's going to be all of this part of the function down here. So it starts being negative here, and it's going to stop being negative here. So this is where the function is negative. It's going to be from here to here. So let's go ahead and say that's going to be from negative 8 all the way until positive 2. And then that's going to be the last interval. And this is where the function is negative or below the x-axis. Here's number 3. For number 3, we have this function f of x is equal to 2x squared plus 7x minus 15. This is the first function we have here where a does not equal 1. But because a is prime, we know the two factors have to be 2x and 1x if we can factor it. Now let's see, for negative 15, I'm going to choose 5 and 3 here to begin here. We know one has to be positive, one has to be negative. We're looking for positive 7 in the middle. Let's try positive 5 and negative 3. If we pair this up across, 2x times 5 is 10x, and then x times negative 3 is negative 3x, so 10x, take away 3x is that 7x in the middle, so that works out well. So our function here is going to be f of x is equal to, I think our first binomial is going to have this 2x, and then our second binomial is going to have this 1x. So 2x, the plus 5 is going to go on the outers, and then the minus 3 is going to be the inners. So this right here, this pairing is going to be the outers, and this pairing is the inners. Okay, so if we FOIL that out, that should work. Now, what does this tell us? Well, we can find out our zeros now. If we go ahead and set this equal to 0, you can find out that if x was equal to 3 over 2, or 1.5, then this binomial would become 0. And if you set this binomial over here equal to 0, then if x was equal to -5, then that would become 0. So what are our zeros, or our x-intercepts? Let's go ahead and write those down. One of them is going to be 3 over 2, or 1.5, comma 0. And the other 0 is going to be -5, comma 0. All right, so those are our two x-intercepts. Just to make a quick sketch here, this is what it would look like. So here's our x-axis, here's our y-axis. Positive 3 over 2 maybe would be somewhere over here. And then this -5 would be maybe somewhere over here. So just a rough sketch, it would open upwards just because A is positive, and it would be maybe a little skinnier than usual just because we have a value of 2, which means it's getting vertically stretched a little bit. So for the domain, just like for all quadratics, it's going to go to the left and to the right forever, so -infinity to +infinity. And then the range here is probably the most one that takes the most amount of work here. We have to figure out the lowest point, which is down here. And we know the highest point, it does go up forever. So we know that we're going to need a bracket on that lowest point, and then it does go up forever. So we're going to use parentheses there. Okay, so let's go ahead and see if we can find out this lowest point. Again, when we do that, we have to find out the AOS first. So that's going to be, let's go ahead and use -b over this 2a. And let's see, that's going to be -7, right? B is 7, so it'll be -7 over 2a. 2 times 2 would be 4. And so I think we're going to have this -7/4 for our AOS. So that's going to be our x value for the vertex. So if we do f of -7/4, that's going to be 2 multiplied by this -7/4 squared, and then plus 7 multiplied by this 7/4, or -7/4 rather, and then minus 15. Okay, so you can go ahead and do this by hand or plug it into a calculator. I believe if you plug it in, we're going to end up with -21 and 1/8. So if you need to pause to go ahead and try and do that, feel free to do so. But if we go ahead, we're saying that the vertex for this function here is going to be -7/4, comma, -21 and 1/8. So one I wrote as a mixed number, one I wrote as an improper fraction, but doesn't really matter. Okay, so what's the lowest part of the function? That's this value here. The lowest part we just found out is -21 and 1/8. So we're going to write that in. It's going to be -21 and 1/8. That's the lowest part of this function. All right, so that one was the one that takes the most work. The rest of this isn't too bad. When is this function increasing? Well, starting from here, this is the x value where it starts increasing, and that's going to be increasing from here on up. So it starts at what value? That's going to be -7/4. So let's go ahead and say it's going to start increasing at -7/4, or -1 3/4, and it's going to increase forever after that. Okay. What about when the function is decreasing? Well, it's going to be decreasing, decreasing, decreasing from the left all the way up until that point of -7/4. So we're going to use this one again. So it's going to be from the left, which is -infinity, all the way to -7/4. And then it starts increasing after that, right? When is this function positive? Well, that's going to be above this x-axis. So that's talking about over here and over here. The function is positive. So the function is going to be positive from the left all the way up until this x-intercept over here, which is going to be -5. So until -5, then it goes below the x-axis. And then the function starts being positive again from this x-intercept, which is 1.5. And it starts being positive if you keep going up to the right over there. So we can say that from 3 over 2 up until +infinity, that is also going to be positive. So it's positive over here, and it's positive over here. What about when the function is negative? Well, that's going to be below the x-axis. That's going to be down here. And it's really just negative between these two x values. So from -5 up until +3 over 2, it's negative, and then it starts being positive to the left of that and to the right of that. Here's one more we can try together. For number 4, we have this function of f of x is equal to 3x squared plus 7x minus 20. So similar to the last example, a does not equal 1, but 3 is prime, which is kind of nice. So we know it has to be factors of 3x and 1x if we can factor this. For the negative 20, I don't know, maybe we can start with 5 and 4. Let's see if we can make this work. I think we can, so I'm going to make this 5 negative and the 4 positive. And if we pair this up diagonally, 3x times positive 4 is 12x, then x times negative 5 is negative 5x, so 12x minus the 5x would get you that positive 7x in the middle. So let's see if we can write this in factored form. F of x is equal to, and we know the first binomial starts with 3x, and the next binomial starts with just 1x. Now 3x is going to be paired with a positive 4, so those are outers, and then x is paired with this minus 5, that's going to be the inners. So again, this 3x and 4 are the outers here, and then this x and minus 5 are the inners. So let's go ahead and use these factored binomials and find out the zeros. So if you set this equal to 0, you add 5 and divide by 3, then x would equal 5/3. That would be one of the x-intercepts or the zeros. And for this one, what makes this become 0? That's if x is negative 4. So what are the zeros or the x-intercepts here? One of them is going to be 5/3, comma 0, and the other one is going to be negative 4, comma 0. Those would be the two x-intercepts. So we want to just make a rough sketch so you can see what this visually looks like. Again, a is equal to 1, so we don't have to worry about that. The function is going to open upwards. 5/3, comma 0, that's 1 2/3, maybe that's somewhere over here. And then negative 4, comma 0 is maybe somewhere over here. So we go ahead and see what this looks like. It would look something like this. And that would be a good, maybe rough sketch here. Okay. Let's go ahead and check out the domain. It is a parabola, so it's going to go to the left forever and to the right forever. So that's going to be the same. For the range, we do have a lowest point, so we need a bracket. And then the highest point, it does go up forever. All right, so that's going to stay the same here as long as a is positive. So to figure out this lowest point here, we do have to figure out the vertex. So let's go ahead and try that. So to find that lowest point, let's go ahead and find the vertex. But to do that, we'll start with the AOS. So x equals negative b over that 2a. Negative b would be negative 7 over 2a, which would be 3 times 2, which is 6. So I think negative 7, 6 would be our vertex, or at least where the AOS is in the middle. All right, so now that we know the AOS, we can go ahead and figure out the lowest point here. So f of negative 7, 6. That's the x value. Let's figure out the y value now. That's going to be 3 multiplied by this negative 7 over 6. That's going to be squared plus 7 multiplied by negative 7 over 6, and then minus 20. Okay, so feel free to go ahead and do out that work and figure that number out, but I'm going to go ahead and tell you that it's going to equal negative 289 over 12, which you can also write as a mixed number if you want to write and say that's going to be negative 24 and 1/12. All right, so feel free to pause to go ahead and figure that out, but that would be the y value. And so the vertex here, we just figured out the x and the y value. The AOS help us with the x value. That's going to be negative 7, 6, or negative 1 and 1/6, and the y value is going to be negative 24 and 1/12. All right, so that's going to be the lowest point here. So for this lowest point, we just figured out it's negative 24 and 1/12. Let's go ahead and write that in, negative 24 and 1/12. Okay, now when is the function increasing? Well, let's go ahead and see if we can figure that out. For this increasing, it's going to start from down here. So what's this x value? It's going to start from this negative 7 over 6, and then it's going to just start increasing from there on out. Okay, so it's going to start increasing from, let's put a parenthesis here on negative 7 over 6, and it's going to increase forever as we go to the right. Now, what about when the function is decreasing? Well, it's decreasing forever from the left all the way up until this vertex here. So the left forever means negative infinity until that negative 7 over 6. Okay, that would be when it's decreasing all the way up until the vertex. What about when the function is positive? That's going to be above this x-axis, so it's positive over here and over here. Okay, so it's positive from the left. So I'm going to go ahead and put parentheses from the left all the way until when this x-intercept. So it's positive, 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 positive up until here. That's going to be -4. So it's going to stop being positive when you hit -4, and then it's going to dip below the x-axis and start being positive again over here at 5/3. So it's going to start being positive at 5/3, and it's going to be positive forever after that, right? So from 5/3, and it's going to be positive as you keep going to the right. Lastly, when is this function negative? Well, here's the x-axis. It's negative down here. So it's going to start being negative here, and it's going to be negative all the way up until you hit here. Okay, so it's negative from here to here. At -4, it is going to start being negative, and then when x equals 5/3, that's going to be when it stops being negative. Okay, so there you have 4 different examples of looking at some quadratic functions where we had to figure out some different intervals, where we can find out the intervals of the domain, the range, the increasing, decreasing intervals, as well as the positive and negative intervals. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.